Okay, we're going to talk about very briefly geometric series, which a geometric series is simply summing up a geometric sequence. So you should remember a sequence is just a set of numbers that follow some pattern, okay? And there's two types of patterns that we focus on in this class, arithmetic and geometric, all right? And a series just takes that sequence and adds up all the terms that I want. Now, to find the sum of a finite geometric series, use this formula. S sub n is equal to the first term times 1 minus r to the n divided by 1 minus r. R cannot equal 1. That should make sense because if r equaled 1, you get 1 minus 1 on the bottom, which would be 0, and we can't divide by 0. So basically, we'll never have a problem where r equals 1, where n is the number of terms, and a1 is the first term, and r is a common ratio. You should write all that stuff down. The sum of an infinite geometric series, assuming that r is between negative 1 and 1. So let's pause right there and discuss that real fast. If your r value is not between negative 1 and 1, you cannot find the sum of an infinite geometric series. So if I was to ask you a problem saying, hey, find the sum of this, geometric series, but r was, let's say, 3, okay? So we were multiplying by 3 each time to go from term to term to term, or negative 3 even, okay? That would not give me an r value of between negative 1 and 1, so it would not count. So I could not do it, so you would just say not possible. But if you're given an r value that's between negative 1 and 1, then you can use the formula s equals the first term divided by 1 minus r. Alright, so let's look at a few problems. So we have 1, 2, 4, 8, 16, and then it tells me that the total number of terms is 16. So you might be wondering, is this arithmetic or is this geometric? Well, from 1 to 2, you add 1. To go from 2 to 4, you add 2. Okay, not arithmetic. All right. To go from 1 to 2, you would multiply by 2. Okay. To go from 2 to 4, you would multiply by 2. And you can see that the pattern holds true. I continue to multiply by 2. So that means r is equal to 2. My first term is equal to 1. All right, so a sub 1 is equal to 1. And my n is 16. So with that information, you should be able to use the formula S sub n, because this is a finite, because it has an ending amount. Okay, if you didn't know what finite means, it means it has an ending. Okay, so S sub n, all right, so the sum of n number of terms is equal to the first term, a sub 1, times 1 minus r raised to the n power, that's an n, divided by, all of this is divided by, 1 minus r. Okay, so for this problem, S sub 16, n is 16, is equal to the first term, which is 1, times 1 minus, okay, we said that r was 2, raised to the 16th power, close that, divided by 1 minus r, and r is 2, so 1 minus 2. A couple things I want to point out here. I put r in parentheses. Okay, that's because you don't need it when r is positive, but when r is negative, it's very wise to make sure you put r in parentheses. The other thing, make note of where the exponent is. Is it inside the parentheses or is it outside? It's outside. It needs to stay there, okay? So now we're ready just to throw this guy in a calculator. So the sum of the first 16 terms is simply going to be, once I get this to turn on, 1 times 1 minus 2 raised to the 16th power divided by, make sure you put the denominator in parentheses, and you get 65,535. 65,535. Okay, all right. Next problem. All right, so we have the Greek letter epsilon, okay, the sum of the first 7 terms, so from term 1 to term 7, all right? And we have our explicit formula right here. All right. Now, this is our explicit formula. Let's refresh our memory. What is the explicit formula for a geometric series, assuming nothing's been plugged in? Like we're just looking at like the general format. It's a sub n is equal to a sub 1 times r raised to the n minus 1. Now, looking at this idea, a sub 1 times r raised to the n minus 1. When you look at this guy over here, what is going to be r? Well, you see how this r in the general format is being raised to the variable minus 1? The 4 is being raised to the variable minus 1. So r is equal to 4. Alright, so there are a couple different ways to get the first term. The first term is simply the number multiplying to r. You might look and say, I don't see any number multiplying to r. So then what number could I assume it is? 1. That's right. Now, let's pause right there for a second. Let's say that just didn't make sense to you. You're like, what? How is a sub 1 r? 1? Okay. Well, once again, a sub 1 in explicit formula for the geometric sequence is multiplying to r, okay? So you go look here, you see, I see my r because it's being raised to my variable minus 1, but I don't see a sub 1. Well, what number could be multiplying that wouldn't change anything? 1. But let's say all that still doesn't make sense. Here's another way you can find a sub 1. Here's another way. You could say a sub 1 is simply equal to 4 raised to the 1 minus 1. So then a sub 1 is equal to 4 to the 0, and we know anything raised to 0 power is just equal to 1. Alright, and then n is just my total number of terms, so for this problem that is 7. And that was gross. Alright, so now we can say s sub 7 is equal to the first term, which is 1, times 1 minus r sub n, so that's going to be 4, put that in parentheses, raised to the 7th, divided by 1 minus r, so 1 minus 4. So now we're ready to grab our handy dandy calculator and type this all in. So 1 times 1 minus 4 raised to the 7th divided by 1 minus 4. Press enter, and I get 5461. So the sum of the first 7 terms is 5461. Alright, let's move on to our next example. 4 plus 1 plus 0.25 plus 0.0625 dot dot dot. So hopefully first thing you realize is I don't have an n. That's because this is an infinite situation, okay? Sorry about that. In order to find an infinite, the sum of an infinite geometric series, first we must know what r is, because r must be between negative 1 and 1, otherwise it's not possible, okay? So, for 1, you might think, ooh, I divided by 4, divided by 4, divided by 4. But remember, r is something I multiplied by. So if you can't really just see what r is naturally, you can do this. R is always equal to the second term divided by the first term. But what if you're not sure? What if you think, well, this might not be geometric? In other words, are you sure that you're dividing by 4 each time? Well, you can check that by doing second term over first term, and then doing third term over second term. Well, r is equal to 1 divided by 4 is just 1/4, and 0.25 divided by 1 is just 0.25, which is the same thing as 1/4. So bam, we know that our r for sure is 1/4. Okay? So from there, I can then say, I know my first term, that's just 4. So then it should be pretty obvious to say s is equal to a sub 1, 4, divided by 1 minus r, so that's 1/4, 1 minus 1/4. Alright, now this is just a calculator situation. 4 divided by 1 minus 1/4. Press enter, and I get 5.3 repeating. So the sum of this infinite geometric series is approximately 5.3 repeating. Okay? Alright, one more example. 3 minus 9 over 4 plus 27 over 16 minus 81 divided by 64. Okay. So when you look at this, you might be able to say pretty quickly, that does not look arithmetic to me. Okay? But I'm not sure. But let's check to see if it's geometric. Okay? So you could say, okay, well, I know how to check to see if it's geometric. I just simply take the second term. That's a 9. And I divide it by the first term. And then I compare that to the third term divided by the second term. And if these give you the same number, then bam, you know that you know what r is, and therefore you know it's geometric. So, negative 9 divided by 4 divided by 3. We got negative 3/4. 27 divided by 16 divided by negative 9 divided by 4. Press enter, and I get Nothing, because my calculator... Ah, there we go. Negative 3/4. So r is the same thing in both times. So r is simply negative 3/4 in both situations. R is simply negative 3/4. Okay, so then I can find the sum of the infinite geometric series by simply taking the first term and dividing it by 1 minus r. So I grab my calculator, I do 3 divided by 1 minus negative 3/4. Press enter, and I get 1.714. So we're just going to round. S is approximately 1.714. So there you go. That's how you do this. All right. This was very much so just a crash course into it. There's a lot of cool stuff in the background going on that I'd love to talk about if you have any questions on. But as far as just how to do it, this is how you do it. All right. Let me know if you have any questions.